everybody. Today we are going to review one of the Medoc main station software programs, the program called Pulses. This program will allow you to create a stimulation profile that has the shape of pulses, like the name of the program. It will allow you to stimulate with the maximum possible rate depending on the type of the thermode of the probe that you are using. So we will start from creating such a program from scratch. We go to bottom left part of the screen and press on Create New Program. Now, you can create Pulses program both for regular TSA probes like 30 millimeters by 30 millimeters or 16 by 16, and you can create it for CHEPS thermode if you have one. It really depends on which thermode you are using. The only difference will be in the maximum rate of the stimulation applied. For the regular thermodes, it's going to be 13 degrees, as this is the maximum rate, and for CHEPS, it's going to be 70 degrees up and 40 degrees down. So let's do this for CHEPS. We create CHEPS in the probe type, and then we create pulses in the method. Let's give it an easily recognizable name. We're going to create heat pulses program first, so let's go for this. Now there are some parameters that you can control and some parameters that you can't control. As I said, maximum possible rate will be always applied, and that is why you don't have a rate parameter to be set up here in the program. You do have the baseline parameter, meaning from which temperature you would like to start. Let's start from 35. You can select the modality. It can be either heat or cold, depending which type of pulses you want to do. We will do both. We'll start from heat. Time before sequence is the time that will pass before the first pulse will start. Let's make it 5 seconds. Trigger allows you to either let the stimulation start automatically or have it manually triggered by you for each trial, for each pulse, or for the whole sequence. So in this time we'll stay with the automatic trigger, but just to let you know that this is possible. Now you have two destination temperatures, one high destination and one low destination. When you work with heat pulses, what is important is setting up the high destination temperature. Let's set it for 49. And the low destination temperature is important if you want to have more than one pulse in the trial. So if I want only one pulse and then go back to baseline and continue to the next one, I can set the low destination temperature on 35, like my baseline, and ask for only one pulse in trial. And then I will receive this type of stimulation. Let me just adjust the scale a little bit. So it's going to go to 49 and back to baseline, like I asked. If, for any reason, I want more than one peak in one set of stimulation, I will set the number of pulses in trial to more than one, let's say for 3. And let's say I want to go to 49, then down to 46, and back to 49 again, etc., etc. So I will set the low destination temperature on 46. And in this case, the stimulation will look like that. It will go up to 49, go back to the low destination, high destination, low destination, high destination, and then go back to baseline. 3 peaks in one trial, just like we asked. But I would like to just create some standard pulses program, so I will ask for number of pulses in trial, just 1, and number of trials, let's say 15. Meaning number of pulses in one sequence. Now, some of you might notice that I left the low destination temperature value on 46 degrees. The reason for that is that the low destination temperature value actually has no meaning if you are not using more than one pulse in trial. Since in previous example I used the 46 degrees for a low destination temperature, I just left it as it is. But you can, when you build your program, you can just put the baseline temperature there. The only thing that is important that the low destination temperature will be lower than the high destination. ISI is interstimuli interval. It will set up the time that will pass between each pulse, all the pulses, and you can either set it on the same value, let's say 10 and 10, and then each time 10 seconds will pass between pulse and pulse, and you can set it. It can be there is a minimum and maximum values. They can be different, and then if you set it, let's say, on 8 to 12, the software will each time randomly set up the time in this range, and this might help reducing the expectation bias of the subject, and since the stimulation will not arrive at the same periods of time all the time. Now, there are two parameters that we, for now, are not touching, and these are the offset parameter. The offset parameter allows us to do a little compensation. Since the stimulation in CHEPS is very rapid, sometimes the actual temperature is a little higher or a little lower than the temperature we asked it to go to. For example, we ask here to go to 49, and actually, when you test it in online mode on the skin, it can be 50, because the stimulation is so rapid that the control is not rapid enough to send it to the precise temperature that we asked for. And the offset parameters are here to compensate for this. So I will show you later how you can set your offset parameter and how you can compensate if the actual temperature you're receiving is not similar to the expected temperature. So I think we're good for now. We set up our baseline, our destination, our number of trials, and the time between the pulses. We can save, go back, and then run the test. Run our program. So we select the patient, we select the program, we gave it easily recognizable name so we can find it in the list of our programs. Then we select body site if we want to, and go to test. Now when I will start the test, you will see that the test will wait for 5 seconds, and then the stimulation will start automatically because we asked for automatic trigger. It will rapidly go to 49 degrees with 70 degrees per second up and 40 degrees per second down, and then wait 8 to 12 seconds and repeat it again. Now I am testing now and demonstrating this to you in demo mode, meaning with no device connected, and of course not on the skin of the patient. As I said, to see if you need to play with offset parameter to compensate a little bit and to make the actual temperature equal to the one that you want to reach, you will need to do the testing in online mode with the device connected, and when the thermode is attached to the skin. And let's say when I'm doing this, my temperature is not as precise as in demo mode, and it reaches a 48 instead of 49. So what I can do, even using the local edit, I can play a little bit with the offset and see which value will bring me to 49 degrees. So I press on the local edit. No, I don't want to save the results. And what is important now is the high destination offset, because this is the destination that we are using for heat pulses. And if my temperature, my actual temperature, as I said, let's pretend it's 48, so if it's lower than the expected destination temperature, I need to decrease the offset value. And if it's higher, I need to increase it. So since we are reaching 48 instead of 49, I would like to decrease the offset. I will put it on -1, and I will see if it is good enough. Let's see. I expect it to increase the actual temperature by approximately 1 degree. Let's see if this is what happens. And indeed, you can see that the actual temperature is increased by 1 degree, exactly the effect I was expecting to receive. And now I can just go back to my program, edit the offset value to -1, and that's it. The good news are that you only need to do this once when you're first setting up your protocol. you need to, before you start your actual test, you need to do this one run in online mode with the thermode on the skin to see if you need to adjust the offset parameter a little bit to have your stimulation maximally precise and similar to the expected temperature. So these were the heat pulses. Now we will stop the test and we will go and back to the main screen. And now we will create the cold pulses program. We go to the program tab, we press on create new program button, again, CHEPS pulses, just like we did for heat pulses, and we'll give it another name. Let's start from a different baseline, from 32 for example, and let's change the modality to cold, because now we want the temperature go down from the baseline to our low destination that we will set in a minute. Time before sequence, let's make it 5. And now we, just for the sake of the demonstration, we can put the trigger manual for sequence. Just to show you how it works and how it looks like. Manual for sequence trigger will trigger the whole set of the pulses, the whole sequence. And manual for trial will wait for your trigger before each trial, before each pulse. So let's set the low destination now to the required temperature. Let's say we want to go to 10 degrees. And the high destination will be our baseline, because we only want one pulse in trial. Well, I will leave the offset parameters for now. We'll play with them later. We want only one pulse in trial, and we want, let's say, 10 trials. Now, please pay attention that in case of cold pulses, the ISI minimum value is 8 seconds, excuse me. Since the cooling the system to such a low temperatures in such high speed is quite difficult for the system, and that's why the system needs this time between the pulses to cool down and be ready for the next pulse. So we will set it again to 8 to 12 and save, go back, and now we will run the test that we just created, demo cold. Now let's see. I asked for manual trigger for sequence, so before the first pulse, it will be waiting for the trigger given by the operator, by you. You can trigger the stimulation either by using the trigger button on the bottom of the screen, or, like I will do right now, by using the T key on the keyboard. And we can see that the stimulation starts from 32 to 10 degrees. And you can see that in this case, again, I'm testing in demo mode, but let's say I'm in online mode with the thermode on the skin. I can see that the stimulation actually is a little, temperature is actually a little lower than the 10 degrees. So it's a little over the expected temperature. It means that we need to increase the offset. So if we are over the expected temperature, high or down, up or down, we need to increase the offset. And if we are below the expected temperature, up or down, we need to decrease the offset. So now we will stop the stimulation. We will again go to local edit and use the low destination offset now and increase it a little bit. Let's increase it by 1 degree. Okay, now we will save and go back and see if it did the effect that we wanted it to do. Start. Trigger. Okay, now we can see that we are very precise, reaching the 10 degrees, and we are good to go. One thing to remember, that the editing we did in what we call a local edit. So it means it's editing the program only for this specific run. It's good for such trial and error process when you want to set up the parameters and make sure that you have it right before you actually put it in your permanent program. So it's important not to forget to, when you stop the stimulation, when you are good with the offset you selected, to go back to the main screen, to select your program, and to put the low destination offset to the 1 degree that we found previously. One more thing that I would like to review here is the topic of events. Many of our customers who use the Pulses program want some time to send a TTL event to some external device like a MRI or a EEG in case the external control, in case called evoked potential test is used. And this can be done very easily using the standard or temperature events. Standard events are a set of events that we know that people often use. We know that it is very popular to send TTL, let's say, to EEG and evoke potential test at the onset of each pulse. It can be also done at the peak, end of trial, and the aux event will allow you to send TTL event out, trigger out at any time point that you like. Fully configurable. So let's say we want onset of each pulse to trigger EEG device with the TTL. And we can also use temperature events. So when some temperature is reached up or down, the trigger will be sent. So just to show you how it looks like, we asked for TTL at onset of each pulse. And now we will run the program, test. And you will see a small asterisk at the onset of each trial. When the asterisk appears, it shows us that the TTL event was sent, and if any external device is connected with TTL cable to our TSA2 device, it will receive the TTL event and it will mark something or trigger something on the external device. So I hope this video was informative and helpful. In case you have any questions about how to set up your Pulses program, you are more than welcome to contact us. Thank you very much.